So the first example here is a full-scale prototype. This was a challenge that our customer brought us. It's a customer in the aerospace market, and they asked us to develop for them or produce for them a full-scale fuselage prototype for a new product a new airplane that they designed. They were going to do cockpit install and pilot testing with that structure. So the solution for that, we produced for them a 10 by 4.5 foot long fuselage in about 4 weeks from the time that they provided us with their fuselage design. We maintained the design wall thickness for their structure, which is about 300 thousandths thick. The body was comprised of interlocking panels and ultimately had an auto body style finish. So this is an example of what that vehicle looked like. This is not the exact product that we produced for them, but it's one that we've done for ourselves to demonstrate the capabilities. Now this fuselage, as you can see, it looks seamless on the screen. It was produced with about 130 panels, and there's two halves to this. We're showing the auto finished half on this side, and then the other half is unfinished. This particular model was about 8 feet long. And the stage of the life cycle that we supported with this project was the tail end of the development stage to validate the design. And then it's been used to ramp up the sales and provide visuals for potential customers to allow them to see the aircraft before the mold and finished product was on the showroom floor. So this is a great example of where you can have a full-size prototype to have the potential customers basically develop pre-sales with them. So then the question is, how did we do it? So that particular model was comprised of over 130 panels. That's pretty tricky because the panels are thin, they all have to lock together. You can imagine it's like a three-dimensional jigsaw puzzle. So we had to design the panels to minimize or eliminate warping and dimensional change. We designed the pack to optimize the thermal management so that we could produce the body panels fast in volume without having distortion. And then finally to be able to maintain the outer surface of the skin. So this floating image here on the screen shows one of the packs that we had for the panels. And as you can see in here, there's maybe 10 or so panels in this pack. There's also some other parts in this file here that we ran along with this particular project. The entire fuselage was produced with a nylon PA12. So this virtual pack here shows what would come out of the HP multi-jet fusion, and it would have come out in nylon 12. The print time for a pack like this would have been probably about 14 to 16 hours. And because these panels are so thin, we cooled them over an extended period of time, something like 30 to 40 hours. So you can imagine as we were producing this fuselage body, we had 130 some odd panels, 10 to 13 panels per build. It took us about 10 builds to produce. So that kind of gives a snapshot of what that looked like from a process flow standpoint. And then this shows a partial assembly here in these photos of assembling the nose cone for that aircraft. We're also sharing an internal image of the nose cone. You can see that there's some unique geometries on the surface, some rectangular pockets. We ended up developing our own joining system for each of these panels, and then a joining tool to be able to join those panels together and have them be structurally sound. So those are just some tricks of the trade for bringing together a large structure like this.